and least square error hypothesis. Okay, so ultimate agenda of this particular topic is that we are going to have train data properly. We should have a train data properly. Otherwise, it's very difficult for algorithms to find out the or predict the particular problem statement which they have given. Basically, we consider these type of problems in as in neural network learning system. Okay, that is neural network learning system, linear regression system, and polynomial curve fitting. So the thing is that it is a continuous learning process. If you have a continuous learning process, so there will be a least squared error hypothesis will be generated. Okay, so what is least squared? It is nothing but like finding the average error which we can accept it. So in a straightforward Bayesian analysis, will show the under certain assumption. Okay, any learning algorithms that minimize the squared error. So when you are teaching, when you are training your system or a machine, we expect that it should be have a less error. It should have a less error. Suppose example like my face, which I am trying for your camera and training for your machine. Okay, so there I am expecting that I should get a 95% good result or accurate result. 5% is acceptable. But if you trained your data and your machine is finding only 50% of your face, the accuracy is 50%, then the system will be failure. Okay, so this is keep in mind, assuming that we should have minimize the squared error between the output hypothesis prediction and the training data. So what is this? It is concentrating means it is concentrating that you are minimizing the squared error between your output hypothesis prediction and the training data. So which gives you a maximum likelihood hypothesis. Okay, maximum likelihood hypothesis. So keeping in this agenda, they started to have continuous learning or continuous learning system which is targeted to design an algorithm in such a way that you should get a less error. You should get a less error. Okay, suppose you train for a particular face or a person and it is finding 95% accuracy by confusion matrix, the algorithm is having a likelihood because it is accepting. That's why I said, like, if you have a person and it is finding 40% of your data trained, okay, and you are expecting a 40% output, so there also it will be having a leading of mean squared or least squared error. Okay, keeping in that statement, here what we are learning means the learner L consider an instance space X. Okay, so what is L represents here? Notation, it is a learner, and instance space is considered as a X here, and hypothesis space is considered as a H. Contain a class of real valued function over X. So we have the parameter called H. Okay, H with leads that your X value instance value leads to the R, means a result, real result. Keeping in that perspective, okay, what they are going to find means each training examples is pair of form of xi and di. So it's a pair of xi and a di, okay, where di equals f of xi plus ei. So ei is a random variable representing a noise. Okay, this is nothing but your noise signal. Okay, once again I'll repeat. For each training example is a pair of the form of xi comma di, okay, where di equals f of function of xi plus ei. So here ei represents what? As I said, it is a noise signal which is added randomly to your data. Okay, so here I defined like f of xi is the noise free value of a target function. Okay, whereas ei represents what? A random variable representing the noise. Okay, the task of the learner is to output a maximum likelihood hypothesis or equivalent to map hypothesis, assuming all the hypotheses are equal to the prior knowledge. Means you should know what is the conclusion here in this slide is that you have a noise free value target function that is represented by f of xi, but still I should have a prior knowledge of what type of error which will be added, what type of noise will be added, so that I can reduce in the training data set. Suppose example, it's very confusion sometimes. Okay, suppose example, if I take it, I am training my face to your machine, but it accepts the data in a straight-wise direction. It is accepting straight-wise direction, but suddenly what I will do during the training, I will try to go for the left side or a right side face. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಸ್ಟ್ರೈಟ್ ಫಾರ್ವರ್ಡಲ್ಲಿ ನನ್ನ ಕ್ಯಾಮ್ರಾ ಕನೆಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಆದರೆ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಲೆಫ್ಟ್ ಸೈಡು ಇಲ್ಲ ರೈಟ್ ಸೈಡ್ ಟ್ರೈನ್ ಮಾಡೋ ಟೈಮಲ್ಲಿ ನಾಯ್ಸ್ ಜನ್ರೇಷನ್ ಆಗುತ್ತೆ, ವಿಚ್ ವಿಲ್ ಲೀಡ್ಸ್ ಟು ದಿ ಬ್ಯಾಡ್ ಟ್ರೈನಿಂಗ್ ಡೇಟಾ ಸೆಟ್ ಫಾರ್ ಯೋರ್ ಮಿಷನ್. ಸೊ ಐ ನೋ ದಟ್ ಆಲ್ರೆಡಿ, ಬಿಫೋರ್ ಓನ್ಲಿ ಐ ನೋ ದಟ್ left and right it won't detect, but still what happens to me, your face to face data set has to be trained very well. So adanne we call it as maximum likelihood hypothesis. Adral represent madbidutte, it will try to represent you that what is a noise signal over there. I hope you have understood this. Then it says that it is a linear function. Okay, it should be a linear function. Means you are training your straight face to your system. But what happens when you take a sidewise this direction or this direction training data set, it leads to the error. But when you go for learning a linear function, what is linear? Linear nothing but your whenever the output means whenever the input changes, same thing output should reflect. Okay, that is called as a linearity. But what happens during the data training, you are expecting a straight line function, but during the training what happens, it may sometimes lead to the error. Okay, there is a difference between your linear line and your error line, means trained data. So it should be very less. It should be very less. It should not lead to the noisy training data set. That is the maximum likelihood hypothesis. Okay, we should note down this one properly. In future, those who are doing a machine learning oriented projects, you should know previously or prior knowledge. You should know that if I teach this particular face what you call the face oriented training image, it may lead to the error anta. So that is says that maximum likelihood least squared hypothesis. Okay, so I hope you understood and you all remember for long term. Okay, what is maximum likelihood and least squared error hypothesis means? You should have a prior knowledge of what type of errors it may added, which should not lead to the error training data sets. Okay, so that is the main agenda. So to find out these things, that is called as a maximize the squared error in setting of your hypothesis. We go for probability density function, and also with the normal distribution. So considering what is probability density function, which is given as p of x naught, which is a limit from 0, okay, 1 over epsilon p of x naught. So your x value should be between your x naught and a change in your x naught. Okay, your x value should be between your x naught and change in your x naught error. That is nothing but your probability density function or a variable. Okay, so based on this you should train your data set. And your normal probability distribution. Okay, we know that Gaussian function. Okay, I used to tell you a lot of examples on Gaussian, because Gaussian is a very important curve which says that, which gives you output positive side or it may be the negative side, keeping the origin as a 0 here. Okay, so based on this particular thing, they have told that normal probability distribution, okay, which says that p of x equals 1 over root of 2 pi variation sigma square, that is variation, into e to the power of minus half x minus mu divided by variations, that is sigma square. So this is the formula which they are going to find that my trained data is falling in a positive side or it may be in a negative side. Okay, so I hope you understood this formula. So this is normally probability distribution function, or else we call it as Gaussian distribution, which will be helpful in training your data set. Okay, that is only we have put up here. And only one thing we have to keep in mind, your h of like HML, likelihood least square, can be given as ARG max P of D with a given of H, which all the elements will be present in your hypothesis. Okay, so which training data set you are training? 1 minute, I'll take an example here. Suppose let me take examples like face recognition. Okay, in the face recognition, what you are going to do means two things you are going to do. One is trained data set and your raw data set. Okay, trained data set and your raw data set. What happens in the trained data set? All your face with different angles you will be trained, okay, which should not lead to the error. which should not lead to the error. I gave you one example. I am using an iPhone. Okay, in the iPhone people or Apple people never expected that Corona will come. We are going to put a mask. Okay, but in spite of that, our algorithms, whatever they have implemented in iPhone, is able to find your face even if mask is put upon your mouth. Okay, so ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, it should not give you that you have wear a mask, I am giving a error for you, I could not recognize your face. Like that it won't tell you. Whether they are predicted or not predicted, I don't know exactly what happened in the previous years. Okay, but still our system is able to predict properly, including noise. Will noise ಏನಾಗುತ್ತೆ? So noise will be my mouth wearing with the mask. Okay, it should be very less, error we have to. Sometimes it will give you that not recognize, sometimes very rarely. Okay, but this assumption you should know before itself, that says your maximum likelihood least square error. Okay, so that is assuming training examples are mutually independent given H. Yes or no? With mask, without mask, it is independent, right? I cannot club it. That is the example I can give. We can write P of, that is probability of D with a given H as the product of the various Di and H. Yes or no? This is my trained data. It is probability of trained data. Already ನಾನು ಕೊಟ್ಬಿಟ್ಟಿದ್ದೀನಿ. I have given all the things in a folder. But as a product of various Di and H. So idru ಒಳಗಡೆ I will be having a two types, with mask and without mask. So whenever you start to give a raw data, maybe in the with mask or without mask, my face recognition has to do. That is the overall agenda of this particular slide. ಅರ್ಥ ಆಯ್ತಾ? ಅಂದರೆ we can write P of D with a given H, that is already trained, as a product of the various ಅಂದರೆ all angles, with mask, without mask, already it is there in the folder of trained data set. Then after giving a input raw data set, should able to recognize your face with the least error, that is nothing but your that is nothing but your HML, which is equal to ARG max with the product of I is equal to lead to the M, then P of with the DI with the given of hypothesis H. Okay, I hope this formula is very important. Directly textbook ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ it's very difficult to understand. That's why I gave an example so that you will understand what is the least squared error. ಎಲ್ಲ average ಮಾಡಿದ್ರು ಕೂಡ my average percentage of error should be very less. Okay, then this all you can leave, not a issue. Okay, then we will move on to the next topic, that is maximum likelihood hypothesis for predicting probability. So we have saw least square error. Now the main output of your prediction algorithm, means output of your algorithm will be predicting probability. ಅಂದರೆ ಎಲ್ಲ ಟ್ರೈನು ಆಗಿದೆ, ರಾ ಡೇಟಾನು ಕೊಟ್ಟಿದ್ದೀರಾ. ಓಕೆ, ಬಟ್ ಸ್ಟಿಲ್ ಮೈ probability of predicting should be good. Suppose you could have seen an example like from yesterday or day before yesterday in the news, the government people are telling that the probability of the corona spread will be more by 25th. And they are predicting probability, they are telling that ಇವಾಗ ಓಕೆ if you consider like other states okay, but ಏನಾಗುತ್ತೆ ಅಂದರೆ by 25th they are predicting that it may be high, after February or March it will be reducing. ಸೊ ಅಲ್ಲೇನಾಗುತ್ತೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಲೈಕ್ಲಿಹುಡ್ ಹೈಪಾಥಸಿಸ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ವಿಲ್ ರೈಸ್ ಟು ದ ಸಮ್ ಲೆವೆಲ್ and it will be dropped on some criteria in the February or a March anta. So that is an example I can give for this particular topic. I hope you understood. Predicting probability. ಸೊ ನನಗೆ ಗೊತ್ತಿದೆ ಔಟ್ಪುಟ್ಟು ಕೊರೋನಾ ಅನ್ನೋದು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಗೊತ್ತಿದೆ, ಬಟ್ ಯಾವಾಗ? ದ ಕ್ವಶನ್ ದೇ ಆರ್ ಟೆಲ್ಲಿಂಗ್ ಯೆಸ್ಟರ್ಡೇಸ್ ಮೀಟಿಂಗ್ ದಟ್ 25th, because they are targeting to the particular date only, that is 25th or 26th. ಹೆಚ್ಚು ಕಮ್ಮಿ ಆ ಕಡೆ ಆಗ್ಬೋದು, ಈ ಕಡೆನೂ ಆಗ್ಬೋದು. ಸೊ ದೇ ಆರ್ ಪ್ರಿಡಿಕ್ಟಿಂಗ್ ಪ್ರಾಬಬಿಲಿಟಿ ಈಸ್ 25th or 26th. ಸೊ ದಟ್ ಗಿವ್ಸ್ ಯು ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಲೈಕ್ಲಿಹುಡ್ ಹೈಪಾಥಸಿಸ್ ಆಫ್ ಎ ಕೊರೋನಾ. I hope you understood this example. Let's see in the theory wise what they have given. Consider the setting in which we wish to learn a non-deterministic, that is probabilistic function f, which leads to the output of either 0 or 1. Okay, which gives you two distinct output or discrete output values. Either it may lead to 0 or it may lead to the 1. ಅಂದರೆ ಕೊರೋನಾ 25th ಒಳಗಡೆ ಇನ್ಕ್ರೀಸು ಆಗಬಹುದು, ಆಗದೇನೂ ಇರಬಹುದು. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ಹಿಯರ್ which may leads to 0 or 1. Okay, but we want function approximator whose output probability function should be 1. ನೀವೇನೇ ಮಾಡಿ ultimate result should be 1. Okay, which leads to the probability function, that is p f of x should leads to the 1. Okay, this is my maximum likelihood hypothesis. Okay, so to do that, to achieve this, how can we learn f using neural network? Now we are going for the implementation. Use a brute force way could be the first collect the observed frequencies of 1 and zeros for each possible values of a x, and then train the neural network to the output the target frequency for each of x. In one example, I will give an illustration here. Once again, listen this statement, we'll go for the example. Use of brute force way could be the first collect the observed frequencies of ones and zeros for each possibility values of a x, and then train the neural network to output to the target frequency for each x. So I'll give a illustration here. Suppose COVID increase ಆಗ್ತಾ ಇದೆ, ಆಗದೇನೂ ಇರಬಹುದು. Okay, that is a probability. For each probability you are finding ones and zeros, that is positive or a negative, that is observed in a frequency wise, what frequency, either it is increasing or decreasing for each day. Then you train that each day into the neural network. ಅಂದರೆ ನೀವು ಪಾಸಿಟಿವ್ ಆಗ್ತಾ ಇರೋವಂಥದ್ದು, ನೆಗೆಟಿವ್ ಆಗ್ತಾ ಇರೋವಂಥ ಎರಡನ್ನೂ ನಾವೇನು ಮಾಡ್ತೀವಿ, ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಟ್ರೈನ್ ಟು ದ ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್, ಹೋಪಿಂಗ್ ದಟ್ ದ ಔಟ್ಪುಟ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, that is 25th, is our target. I hope you understood this example. Okay, so ಆ ಥರ ಅಂದರೆ, but still why the government people are not initiating more on restriction? Because our death rate is very 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 less. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಅದಕ್ಕೆ ನೋಡಿ ಎಷ್ಟೊಂದು ಜನ ಏನೇನೋ ಕಮೆಂಟ್ ಕೊಡ್ತಾ ಇರ್ತಾರೆ, ಆದರೂ ಕೂಡ ನಾವೇನು ಮಾಡ್ತಾ ಇರ್ತೀವಿ, that death rate is very less. That's why they are into the normal position. So that is an example I can give. First, collect observed frequencies of ones and zeros for each possible values of x. Andre x I am getting continuously somewhere data, but in that each value of x you are going to observe a frequencies of either positive or a negative, positive or negative. Okay, so based on that you are going to train for the neural network. You are going to train for your neural network so that the target frequencies of each one I can analyze. That says that maximum likelihood hypothesis for the predicting probability. Okay, so criteria, certain things we have to follow. Certain things, certain orders or certain steps or certain settings we have to do to find your maximum likelihood hypothesis. So let's see first that one. First, obtain an expression for P of D with a given of H hypothesis. Assuming, second step alli ಏನು ಮಾಡ್ತಾ ಇದ್ದೀರಾ, you are going to have assuming that training data D is of the form D with all these parameters, where Di is the observed 0 or 1. Okay, what is the D value it is representing here? The D value is representing that observed 0 or 1 value for f of xi. Andre ella states allo, all the states, towns of Karnataka, they are monitoring the data. Either it is going 1 or a 0, 1 or a 0. But the probability density function for a Bangalore, it is very high. Why? Because the rate of spreading is getting more. Okay, I hope you understood this second step. Then third, both I and Di as a random variable. Obviously I cannot fix that data. Suppose I cannot fix my Mysore value and Bangalore value same. Okay, because there the rate is different and Bangalore rate is different. The days were there, the spreading of virus in a Mysore was more than in a Bangalore, because population of a Bangalore is more than your Mysore, right? But now it is changed. That's why we are declaring a random variables for both xi and di. And di already I told what is that. Di is a observed 0 or a 1 for value of f of xi. Okay, then assuming that each training examples is drawn independently, andre each state in the you are extracting, suppose Mysore, what is 1 or 0, like your Kolar, one is 1 or 0, Chikbalapur 1 or 0, okay, Bangalore 1 or 0, like that you are extracting for each training independently. So by using that concept we can write P of D with the H, given H, as so, which is equal to product I is equal to 1 to m P of xi comma di with the given h value. So what is x? X is nothing but your this value. What is di represents? This value, which is observed 0 and 1. So applying the product rule for this, the above equation with the same we can write it into P of xi. P of xi. Andre each state in the data na we are collected. Okay, I hope just I am giving a link with the virus. Okay, don't write same thing in exam. Okay, so to understand this, otherwise simply if I tell the equation you won't understand what it is. Okay. Yeah, here after considering the above equation, the probability either we consider only two things, right? Either 1 or 0. So for this particular probability, so which is given as like h of xi if di is equal to 1. So already I told example here. Just a minute, I think so power went. I will just log in once again. Yeah, sorry for the inconvenience. Okay. Okay, so uh, here by considering your data like a probability, that is which I can give it as h of xi. I will give an output h of xi if di is equal to 1, or else 1 minus h of xi if di is equal to 0. Okay, so this is the probability of your function, probability function. Then re-express it in more mathematical manipulated form. I can give a equation as, so p of di with an element of your xi, which is equal to h of xi di 1 minus h of xi to the power of 1 minus di. So substituting your equation, okay, I can write it common form as the probability of d with the given h equals product of I is equal to 1 to m h of xi power of di into 1 minus h of xi to the power of 1 minus di into p of xi. Okay, so this is the final equation. Andre, you have collected all the data from a different states considering either positive or a negative data, positive things of a virus and negative things of a virus. Based on that, they kept some threshold. Okay, that is 10. If it crosses more than 10, they will go for the lockdown. So that is one, just I am giving a illusion of it. Okay, so this is how the likelihood hypothesis prediction can be done, prediction probability can be done. Okay, so this is, you will leave it out, it's not important for you. Okay, I hope you understood this maximum likelihood hypothesis for predicting probability. Okay, then we'll go for the gradient search to maximum likelihood in a neural network. Okay, gradient search to maximize your likelihood in a neural network. So as I said, like you will be having a error rates more during the training data set. Okay, what happens during that time? We should find a solution in such a way that the output should return properly, the prediction should get written properly. So that can be easily solved with the gradient search. Okay. Yeah, this I will take it in next class. I will stop it here. Okay. I hope you understood maximum likelihood hypothesis for predicting probability, and also we have saw the maximum likelihood and with least squared error